Dear students, good morning. Let us see the problem on the energy method or Rayleigh's method. Okay, let's see the problem. A shaft of 50 mm diameter, that means they are given this is given data. Let us note given data. Shaft diameter they are given D is equal to 50 mm. You have to convert into meters, that is 0.05 meters. And 3 meters long, they are given the shaft length. Length of shaft, that is L equal to 3 meters, is simply supported at its ends. That means they are given this is the SSB case, SSB model problem. So simply supported beam problem. Okay, this is the energy method or Rayleigh's method. Okay, SSB. Here it carries 3 masses of 100 kg, 140 kg and 70 kg. Okay, here they are given the masses M1 100 kg, M2 140 kg and M3 70 kg. Okay, they are given the distances at 1.25 meters, 2 meters and 2.5 meters respectively from the left support. Okay, so here they are given as per the problem they are mentioned, this is the simply supported beam. Okay, let us take supports A and B. Okay, so in this they are given different lengths. The first one is the 1.25 meters. Okay, 1.25 meters. So let us take 1.25 meters. That is mass A, that is M1. The next one is the 2 meters. Next one is the 2 meters. That is M2. Okay. Next one is the 2.5 meters. Next one is the 2.5 meters. That is M3. Okay, 2.5 meters. But they are given the length of the shaft is 3 meters. Okay, that is the total length. So see once again 1.25 meters, 2 meters and 2.5 meters. Okay, this is the total length, M1, M2, M3 respectively. Here they are given already mass values. Okay, so based on the mass values you need to find out the weight, that is W is equal to mg, basic formula. So here W1 is equal to m1g. As you know, M1 is 100 and G is the 9.81. Okay, after multiplying you will get M1G equal to 981 newtons. Similarly, W2 is equal to M2G. Okay, then you will get to 1373.4 newtons. Similarly, W3, that is M3 into G, 70 into 9.81, you will get to 686.7 newtons. Okay, then they are given E Young's modulus. They are given the Young's modulus is equal to 200 giganewton per meter square. 200 giganewton per meter square. You can convert into Newton per meter square, that is 200 into 10 power 9 Newton per meter scale. Find the frequency of the transverse vibrations using energy method. Energy method is also called as a Rayleigh's method. Sometimes same problem is asked in Rayleigh's method. Okay, you have to find out the transverse vibrations. That is Fn for transverse vibrations. You have to find out that value. The method is energy method or Rayleigh's method. Okay. So here the energy method formula is this energy method is here. The maximum potential energy is equal to maximum kinetic energy. The condition is for energy method, maximum potential energy is equal to maximum kinetic energy. Okay, so as I told earlier, maximum potential energy is equal to G by 2 m1 delta 1 plus m2 delta 2 plus m3 delta 3. Okay, as you know, the basic formula is for potential energy P is equal to mgh is equal to mgh. You know the basic formula. But here we are taking the maximum potential energy. Here the maximum will obtain at the mean position. Mean means half of the height. That means PE maximum will be 1 by 2 mgh. Okay, this is maximum at mean position. This is just P is the mgh. P maximum will occur at half of the mgh value. Okay, here see m and h. Sorry, m and g values. Coming to h, here h is the, you have to take in as a deflection. You have to replace that value with delta of mg delta. Sometimes they are denoted with y. Here you are denoted with delta. So here we have three different loads. So you have to take m1 delta 1, m2 delta 2 plus m3 delta 3. So like that you have to take from this basic formula. Okay. So here you need to find out the delta 1, delta 2, delta 3. You know G value 9.81. Okay. Similarly, maximum KE is the omega square by 2 into m1 delta 1 square plus m2 delta 2 square plus m3 delta 3 square. So this is the maximum kinetic energy. Actually, the kinetic energy, the basic formula is K is equal to half mv square. Okay, you can here, as you know, V is equal to R omega. Here you have to take R as a deflection. Okay, so that's why you will get Ke equal to half m. R omega means here delta omega, where delta is the deflection. Okay, so delta square omega square. So see, you can check here 1 by 2 m delta omega square. So here omega angular velocity is constant for all the values. Let us take outside. So then remaining m1 delta 1 square, m2 delta 2 square, m3 delta 3 square. Okay, so this is the maximum kinetic energy formula. Okay, so here also you need to find out the delta 1 values. So like that you have to find out. So let us find out delta 1 values, delta values, that means the deflection values for different point loads. Let us find one by one. Okay, so first of all you have to find out the delta 1. Okay, so the basic formula here, this is the SSB, it's a simply supported beam. Okay, different point loads. Okay, for that the formula is W A square B square by 3EIL. This is for deflection. We are finding for mass m1, so a1 square b1 square. Okay, so So here you have to consider, here you have to take A values. Here A is the, see, 1.25 meters. You have to always measure from, from left end, that is A. From end you have to measure. Similarly here B is the, this one, you have to measure from the end B, right hand side, from right end B. That means from total distance you have to subtract this value. That means 3 minus 1.25. That is the value is, we will get B value as 1.75 meters. So always you have to measure from right end B. Not only for this one, you have to find A2, B2, A3, B3 for remaining M2 and M3 masses. Okay, so once you get A1, B1 values, okay, you have to substitute. Before that, you don't know I value here. Here I is the moment of inertia. Here I is the moment of inertia. That is 5d power 4 by 64. Here you know D value, that is 0.05 meters. Okay, so 5 into D. What is D here? 0.05. 5d square by 64. 5d square 64. Then finally we will get the answer is 0.307 into 10 power minus 6 meter power 4. This is the I value. You know they are given the already Young's modulus, that is 200 into 10 power 9. They are already given L value. Okay. Here we have a W1, W3 values. The remaining are A1, B1. You know all the values. Just we have to substitute in this equation. Then you will get the delta 1. Okay. So W here W1. Okay. W1 A1 square B1 square by 3EI into L. Okay. So from this substitute, you have to substitute 981. W1 is the 981. Okay, and A1, here A1 is the 1.25. So 1.25 whole square. B1 is the 1.75. 1.75 whole square by 3 into E. What is Young's modulus value here? 200 into 10 power 9. 200 into, okay, so 3 into E into IL. So here E value Young's modulus 200 into 10 power 9 into I value. I already find that value, that is 0.307 into 10 power minus 6 into L value 3 meters. Okay, you have to find this value. Okay, so the finally you will get the L is 8.495 into 10 power minus 3 meters. This is the delta 1 value. Okay, similarly you have to find out delta 2, that is W2 per mass M2. Okay, W2 A2 square B2 square by 3 into E I. Yeah. Okay, here A2 equal to, see, this is the A2 value 2 meters, and B2 is the this value, that means 3 minus 2, that is 1 meter. Okay, like that you have to find it. So the remaining, you know all the values, W2 and A2, B2 and 3EAL, similar to earlier case. So just start. Okay, so similar to this one, you have to substitute like this. Okay, then you will get the answer, because you know all the values. Okay, then you will get the delta 2, that is 9.941 into 10 power minus 3 meters. Similarly, delta 3 per load 3, that is W3 A3 square B3 square 3EIL. Here you have to find out A3. See, here A3 is the this value from NDA up to mass M3, 2.5 meters. Okay, and B3 is the total minus this distance, that is 3 minus 2.5, that is 0.5 meters. Okay, like that you have to solve. Here you have to substitute the answer. Once you know all the values, okay, A3, B3, W3, 3IL, then the answer is 1.9416 10 power minus 3 meters. Okay, so here we already find all the values, delta 1, delta 2, delta 3. Here also just you have to substitute. Let's take the first equation 1 and equation 2. So from equation 1, that is maximum PE, okay, G by 2 M1 delta 1, M2 delta 2, M3 delta 3. You have to substitute direct values. G is the 9.81 by 2. Here M1 is the 100 kg and delta 1 is the, you have to find that value delta 1. See this one, delta 1 8.495 into 10 power minus 3 plus M2, mass M2 is 140 kg into delta 2 is the 9.941 into, okay, so this is the M1 delta 1 and M2 delta 2. Here delta 2 is the 9.91 10 power minus 3. Similarly, okay, you have to add, that is M3 into delta 3 70 into delta 3 1.9416 into 10 power minus 3. Okay, after that finally we will get the answer, that is PE equal to 1166. Okay, we will get this value, potential energy. Okay, next similarly you have to take maximum KE. Okay, the formula is omega square by 2 plus, here M1 is the same, similarly earlier, where M1 is the 100 into delta 1 8.495 to 10 power minus 3, okay, whole square plus, and M2 is the 140. See, you can check here, 140 into all the same values, 9.941 into 10 power minus 3. Okay, this is a M2 delta 2 square plus M3 is the 70 into, this is delta 3, 1.9416 to 10 power minus 3. See, delta 3 whole square. Okay, so finally we will get the value, that is KE, maximum KE into 658 into 10 power minus 3 in terms of omega square. We will get the value, but here we need to find out the natural frequency. For that, okay, you have to find out omega n value. Okay, so that means you have to equate this equation 1 and 2 values. Okay, equate 1 and 2. From that we will get W equal to, okay, so yeah, W square. So from this you can easily find out the W value, that is 33.076 radians per second. Okay, this is nothing but omega n, natural frequency. But as you know, omega n is equal to 2 pi Fn, but we need Fn value, that is omega n by 2 pi. Okay, so from that you can take the formula Fn is equal to omega n by 2 pi. Okay, So 33.076 by 2 pi value, you will get the answer 5.264 hertz. This is the natural frequency, units are hertz. Like that you have to solve the problem. Okay, thank you.